Hello! Alright, today's lesson is going to be all about multiplying and factoring. So factoring is going to be something that's really important not only for this unit, but for most of the rest of the units in this whole semester. So that's going to be something you're really going to want to know how to do. And again, you're going to do it next year too in Math 3. So example 1. So we have to multiply these two things. So hopefully right away you see, well, we have a 4 on the outside of parentheses, so we're going to distribute that 4. So 4 times 3x squared is 12x squared. 4 times 4x is 16x. 4 times negative 8 is negative 32. So that would be our answer. Example 2. So again, we have a 3ab this time on the outside of parentheses, so I'm going to distribute that whole thing. So 3ab will be multiplied times 5a squared, plus, so we keep our same sign, plus 3ab times b. So now when I'm multiplying two monomials like this, I like to do the numbers first. So 3 times 5 times a squared times b. And then there's no other numbers, so 3 times a times b times b. So now it's a little, you don't have to do this, but it just makes it a little bit easier to see how you're going to multiply these two things. So 3 times 5 is 15. A times a squared would be a to the third. And then we still got that b there. And then plus 3a, and then b times b is b squared. So example 3. So this time we have two things that we have to distribute. So I'm going to distribute the 3x and also the 6x because these are separated by a plus sign. So 3x times 5. So 3 times 5 is 15, and then I still have an x, so 15x. 3x times negative 3x. So 3 times negative 3 is negative 9. X times x is x squared. And then I have a plus sign, so plus 6x times x. So that's just x times x is x squared, so 6x squared. 6x times negative 2, so 6 times negative 2 is negative 12, so negative 12x. So now I look for any like terms. So I got a 15x, 12x, negative 9x squared, and positive 6x squared. So remember, we start with the highest exponent, so I'm going to start with the x squared first. So negative 9x squared plus 6x squared. That would be negative 3x squared. And then 15x and a negative 12x, so 15 minus 12 is 3, so plus 3x. And that would be our answer right there. So moving on to example 4. So I got to write this in standard form, which we've been doing each time. This is standard form, this is standard form, standard form. So basically they're just telling us to find the answer the same way that we've been doing it. So I got a 4x plus, so that means the 4x is not part of the thing that's going to be distributed. Only the 8x is going to be distributed because that's the only thing that's being multiplied times the parentheses. So if I have an 8 times this 1 here, that's just 8. X times x squared. So I add the exponents, x to the 1, x to the 2, so x to the 3. X times x squared is x to the third. 8x times negative 2x. So 8 times negative 2 is minus 16, or negative 16. X times x, x squared. And then I have a plus sign here, so I'm not multiplying that by anything, so it's just plus 3x squared. So now I look for like terms. So first thing I'm going to look for is the biggest exponent. So 8x cubed, there's no other x cubes in there, so that's going to stay the same. So 8x cubed. Then I have a negative 16x squared and a positive 3x squared. So negative 16 plus 3 is negative 13x squared. And then I have just that 4x by itself. So it'll be plus 4x. So now it's in standard form because the highest exponent comes first. Combine all like terms, so we are done. And then example 5. So this one gets a little trickier here because all these things are being multiplied times the parentheses. So that means I have to distribute this whole thing to anything that is separated by a plus or a minus. So I have 3 things in there to distribute it to. So I'm going to write these out separately. So 5x squared y squared will be multiplied times 4x to the 5th, and then plus 5x squared y squared times 9x squared y to the 3rd. And then minus, so minus 5x squared y squared times y. So now I just gotta clean these things up a little bit. I gotta multiply and combine like this. So first thing I'm gonna do is I'm gonna multiply these two numbers. So if I'm multiplying these two things, 5 times 4 is 20. X squared times x to the 5th is x to the 7th. Y squared, and then there's no other y, so just y squared. So now I look at all the numbers first. So 5 times 9, that's 45. Then I go in alphabetical order. So x squared times x squared is x to the 4th. Remember, when you're multiplying two at the same base with that both have exponents, add the two exponents. Y squared times y to the 3rd will be y to the 5th. So I keep the same sign, so minus 5 times 1, or just 5. X squared, there's no other x's, so this will stay x squared. And then y squared times y is y to the 3rd. So now I want to look to see, do any of these have any like terms? Are any of those exponents the same on the same variables? No. No like terms, so that means I am done with my answer. So that one seemed kind of complicated probably for some of you, but it's really not that difficult. The math is not that difficult. It's just knowing what you need to do, what you need to combine and multiply. So with a little bit of practice, I think you guys will get good at that. All right, so on the next page, we're going to be talking about factoring. So when we're factoring, we're looking for something that goes into both numbers or both variables. So there's some examples up here. So the numbers that are multiplied give you factor, and the factor is something that goes into those numbers, like I said. So the number 12 can be factored in different ways. So if I multiply 1 times 12, that's one way to factor the number 12. Also, 2 times 6 would equal 12, so that's another way to factor 12. 3 times 4 would equal 12. And then 1 times 4 times 3, 2 times 2 times 3. So factoring is something we've done, especially when we've been using the radical signs. But now we're going to be using variables a little bit too. So in example 6, we have to find the greatest common factor. So that's what GCF stands for. So greatest common factor is the biggest number that goes into 2 or more monomials, or 2 or more numbers, or 2 or more variables. So for example, what is the biggest number? What's the greatest common factor that can go into 4 and 6? So what number is divisible by both 4 and 6? So they're both even numbers, so I know 2 goes into both. And 2 and 2 go into 4. Those are the only numbers besides 1 and 4. 2 and 3 go into 6, but 3 does not go into 4. So the biggest factor would be 2. For variables, I could multiply x squared times x squared, or x to the 3rd times x to the 1. Or I could for x to the 6th, I could multiply x to the 3rd times x to the 3rd. Or x squared times x to the 4th. Or x to the 1 times x to the 5th. So we're looking for the greatest common factor. So that'd be x to the third. And then when we're trying to find the greatest common factor of these two things, so the greatest common factor for the number we said was 2. For x to the fourth and x to the sixth, that would be x to the third. So 2x to the third would be the greatest common factor for those two things. So the first step when factoring is always to look for the GCF, or the greatest common factor. Find the GCF and then factor the GCF out of the polynomial. So if I look at all three of these terms, what number would go into all of those things? Hopefully this one's not too difficult to see. That 5 would go into all of them. So I'm going to factor out a 5. So when I'm factoring this, it's kind of like the reverse distributive property. So I take out 5 from each of these terms, and then I'm going to divide each one by 5. So when I started with 5x, but I divided this thing by 5, so now I'm just left with x squared. Or I started with 5x squared. Okay. This one started off as 10x, so I keep the same sign, so it's going to be plus. But then I factored out a 5, so 10x divided by 5 would be 2x. This one was 30, but then I factored out a 5, so 30 divided by 5 would be 6. So that's how that one would look like after you factor it. As you can see, a 1, a 2, and a 6 are the numbers that are left on the inside. Those do not have any more common factors besides 1, so that is good. Next one, 32x to the 5th and 60x to the 4th. So we know the two numbers are even, so for sure 2 goes into them. So 16x to the 5th minus 30x to the 4th. But these are still even, so that means that I can still factor out more. So sometimes if you're not going to see, whoops, I'm going to do that. You're not going to see right away what number goes into both of these things, or what's the biggest number. So you might have to try multiple times. So I still can see that 2 goes into both of these things. So I already have a 2 out here, so I'm going to take out another 2. So now 8x to the 5th minus 15x to the 4th. And now on the outside I have 2 times 2, or 4. So 8 and 15 are the numbers that are left. They do not have any common factors because 15 is 3 times 5. 8 is 2 times 4. So no common factors. But we do have some variables in there that can be factored out. So I am going to look for the biggest exponent. Since they both have a base of x, I need to look, or excuse me, I look for the smallest exponent, which would be 4. So 2 times 2 is 4, so that's I have a 4 on the outside already. So this is what it looks like. So 4 times 8x to the 5th minus 15x to the 4th. Now I'm going to factor out x to the 4th. So 4x to the 4th. 8x. I had 5x to the 5th. I took away x to the 4th, or I divided by x to the 4th. So I'm just left with x to the 1, or x. Minus 15. So I had x to the 4th. I factored out, or I divided by x to the 4th. So now there's no more x's left. So this is what it would look like factored. And then example 9, factored completely. So first thing I'm going to do is look at the two numbers. So I know that 7 goes into both of those numbers, so I'm going to factor out a 7. I know that g and g are both in here. So what is the smallest exponent? That would be to the 5th. So I want to take out as much of these two things as I can. So k, they both have a k. Squared is the smallest, or 2 is the smallest exponent. So I'll take out k squared. So now I'm dividing each of these terms by 7, g to the 5th, k squared. So 7 divided by 7 is 1. G to the 6th divided by g to the 5th. I had 6 g's. Took away 5, so now I have 1 g left, or g to the 1. Had 3 k's, or k to the third. Took out 2 of them, so now I just have k to the 1, or k. Then we have a minus sign. So negative 35 divided by 7, that would be 5, negative 5. G to the 5th, we took out g to the 5th, so now there's no more g's left. K squared, we took out 2 of those k's, so no more. Oops, I should not have done that. No more k. So this would be our answer. So I'm going to skip that last example because these have been some long notes. We can go over it in class.